Welcome to Maths with Bob. Today we're looking at a series application called Superannuation. And I always recommend you just first up draw a timeline, and then on the timeline you would put the start here and just put some years, 1, 2, say 3 years, and then dot, dot, dot if you like. Always put the row at the end. This is the 20th year, and then maybe step back a couple, 19, okay. Dot, dot, dot. Okay, so here we have the years marked on our timeline, and we now have to invest this money at the beginning of each year and at the end of each year. So I'm going to go up here and say, okay, well, the first $500, let's put it in 500. There's another 500, another 500, okay, another 500, okay. Right down here, it's another 500 here, okay. And you can see here, right at the, that was the 19th, that was the last amount, okay, at the beginning of the year. Okay, so how about at the end? Let's have a look, where would that be? Well, we'd actually now start here. There'd be 500, 500, 500, okay. There'd also be one at the 19th year, 500, and then also right at the 20th year, okay, 500, so at the end of the 20th year. Okay, so we have all these different amounts flying through time, and you can see here, I'm now going to actually just write down, okay, how much interest they're going to accumulate. So this will be 500, 1.08 to the power. Now you can imagine this is going through for 20 years, so that's going to be 20. The next amount, we're going to try and find the total, 500, 1.08. You can see here that'll be 19, etc. Dot dot dot, and the last amount would be there'll be a 500, and that would be only going through for 1 year, 1.08. Obviously, we are compound interesting each of these amounts, so using 8% per annum over 20 years. Now let's have a look at the. Now this is, remember, this is the beginning, so you might like to write down here. This is the okay. Let's write down B for beginning. Okay, and let's write down here E for end. Just write end. Okay, all right. So let's actually write down what the end of the year ones would accumulate to. So let's have a look. Well, you can see here the first 500. Okay, is going to be 1.08. Now you can see here it's actually only going to be for 19 years. Okay, 500, 1.08, 18. Okay, plus. Dot, 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 okay, and then there's the 500, 1.08 for 1 year, and the last amount, which should just be $500. Basically just going in and not earning any interest, okay. All right, okay, so let's actually try and work out what all this is going to add up to, okay. The first idea, I think, is we would take out a common factor of 500 and rewrite it, so let's actually do that. Let's take out a common factor of 500 and reverse the series, okay, 1.08 plus 1.08 squared plus dot 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 plus 1.08 to the power 20. Okay. All right, okay. Let's try doing it with this other one. Okay, we're going to go 500. Okay, it's going to be now. Okay, so we can see here there's actually going to be a times of 1 here on the end, 500 times 1. So this is going to have a 1 instead of a 1.08 plus now 1.08 plus 1.08 squared plus dot 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 plus 1.08 to the power 19. Okay, you can see here obviously at the beginning, hopefully you can see here it's going to earn a little bit more interest, but how much more? And let's have a quick look at the how we'd work this out. Well, okay, so this expression here would be what? 500 times the, okay, this is the beginning, would be 500 times the sum of, now how many terms? Well, there's 1 to 20, so we know it's sum to 20. Sum to 20, and we'd use the sum to n terms formula for a geometric series now, because this is a geometric series. The first term A being, let's have a look, what would the first term in this one be? Well, the first term you can see here is A is actually 1.08. And over here, what's the first term when I rearrange this one? The first term is 1 here. You can see they both have a common ratio of 1.08. Okay, so let's actually go back and try and work these sums out. So A, and this is 1.08. Now it's going to be 1.08 to the 20 minus 1 all over 1.08 minus 1. Okay, so 500 times that. Okay, let's have a look at the end of the year. Okay, so it's going to be what? 500 times, again, sum to 20. Now, why the 20 terms? Well, there's 1 to 19 plus that 1 at the front, so that makes 20 terms. So it's still going to be sum to 20. Sum 20. The only difference here, you can see here the first term is 1 instead of 1.08. So it's 1 times 1.08 to the 20 minus 1 all over 1.08 minus 1. Okay, so you can see here that, in fact, the totals, well, let's have a quick look. What are the totals? Well, the totals will be, let's write the totals in another colour. Okay, green. Okay, so the total for the beginning will be, when you put that into the calculator, it's about $24,711.46. So this is actually equal to, okay, $24,711.46. Okay. Okay. If you find the sum of this series at the end, it's going to be, let's write down here. So this is begin. All right. Beginning total and the end total would be equal to, let's have a look. It's going to be about $22,880.98. Okay, so it's going to be 22,880.98 cents. Now you need to put that into the calculator. Okay, so you can see here there's about, I think I worked it out, about $1,830 difference between putting it in at the beginning and the end of the year. Okay, you can see here that the series are very similar, and just that the first term is 1.08 for the beginning and just 1 at the end. All right, thank you for watching. Bye for now.